Okay, so great. So thank you. I want to start off by saying, it's really an honor for us to be out here. We spent a lot of time, obviously working away, in our bedrooms or our lounge rooms or whatever, and we've been working on this project now for I would say, 4 years or so. In my case, perhaps a little bit less in Steph's case, maybe 3 years or something. But so for a long time, we finally got to the point where we're, very comfortable coming out and speaking to people about it and telling people about it. And so, that's something that makes us, very happy. Obviously, especially here in Atlanta, which is, a place which, means a lot to me. I still have a little apartment here, and I still come here regularly because I like it so much. Today, we're going to talk about Ceylon. I'm going to preface it with, some, just a little disclaimer that I usually start off with. I want to say that, everybody on my team, we consider ourselves Java programmers. We consider ourselves part of, the Java community, part of the Java ecosystem. So what that means is, if I make comments about Java, which sound kind of critical, which identify problems with Java, that's purely from a technical perspective of, wondering how to go about making things better. And the truth is that, in my personal opinion, a lot of the criticisms of Java are, kind of quite misplaced. And I frankly disagree with a lot of the negativity that you'll sometimes see, in some kind of area, from some corners, with respect to Java. In fact, I think Java's an excellent language, and that there's some things which get criticized about Java, which I don't think are problems. Having said that, that doesn't mean that there's nothing wrong with Java, and it doesn't mean that looking forward, we can't, identify things that are wrong with Java and ask, how can we make them better? What were decisions that were made 15 years ago when we knew less than we know now, that were mistakes that we can't really fix in Java because of the need for backward compatibility. Ceylon, what is it? Well, it's a programming language. It's a programming language that's designed to run on virtual machines, okay? Which is to say, it's not a systems programming language, okay? It doesn't attempt to compete with C++ or C or Rust or what have you. Specifically, as of today, it runs on the Java, on the JVM, or on any JavaScript virtual machine. That's, I guess, an open-ended list. In the future, we would love to support, for example, we're looking, we're keeping an eye on the concept of supporting the Dart VM from Google. That would be a very interesting platform for Ceylon, probably match Ceylon very, very nicely. It's a language that's defined by a specification. The specification was written before we actually started working on writing the compiler. What that means is that when you start working with a specification, you wind up with a language with, less corner cases, less cases where you kind of have to, to figure out what the language does, you kind of have to find out what the compiler does. It has a syntax that looks quite conventional, quite boring. If you stick a fragment of Ceylon code on your blog, it's likely that most of your audience is going to understand more or less, basically what it does, right? But that's a little misleading. The syntax is actually a lot more flexible than some other curly brace languages. It's a language with a very powerful and elegant type system, which I'll talk quite a lot about in this presentation. It has built-in modularity. Okay, so modularity is a core construct within the language, within its tool set. Everything we do revolves around building modules. It has its own language module. That's like you can think of the language modules being something equivalent to kind of java.lang, maybe some bits of Java util. So it's its own language module, which is abstracted away from the details of the virtual machine, and its own SDK. That's a set of, a set of modules which provide, some of the functionality that you would expect, that you find in Java SE. And it has excellent tooling, including, a really great, really complete IDE. Which is in contrast to most of the other newer languages. So what can you use it for? Where can I actually, be able to find Ceylon? So first of all, it runs on Java SE together with the Ceylon module runtime, which is a little wrapper around JBoss modules, which is itself a very very small module runtime. It's the core kind of microkernel of JBoss application server. And it's a very simple thing that just manages peer-to-peer class loading and dependency resolution. It can run in any OSGI container. So for example, we started building some parts of our IDE in Ceylon, and we deploy them on Eclipse as the Ceylon car module deploys as an OSGI module because Eclipse is a big OSGI container. It runs on Apache Felix, on Wildfly and Glassfish, and you can use, you can deploy your Ceylon module as a module archive, and then you can actually connect it to, a servlet engine or something like that. It runs on Vertex. How many people here know what Vertex is? Okay, cool. That's quite a few people. So Vertex is like an attempt to bring the architecture of Node.js to the JVM. So it's a project run by Tim Fox at Red Hat, and it now has full support for Ceylon. So you can write your Vertex modules, your Vertex components in Ceylon, and deploy them directly on Vertex through its kind of native Ceylon support. It runs on Node.js. So Node has a module loader called the require function, which you can use to load a Ceylon module that's compiled to JS, and it will run in any web browser. So the modules we compile for JS adhere to a kind of a rather vague specification called Common JS Modules. What that means is that you can use it with require JS or I think there's a couple of other things that would work as a module loader on the web browser client. Additionally, you can use it essentially in any Java program via a Bootstrap API, which you can use to kind of start up not a proper module runtime, but kind of a parent-child class loader architecture and start off loading Ceylon modules. Coming very soon, it will have support for Java EE integration with, certainly we're looking at the ability to be able to write a war directly in Ceylon and just deploy it straight to your Java EE server. Obviously, the first question everybody asks is interop, right? So there's two kind of ways you can go about using Ceylon, writing a Ceylon module. You might write a module which is supposed to be cross-platform, right? So it's supposed to run on both Java and on JS. So it'll execute on both virtual machine environments. It'll depend only on other modules which are cross-platform modules, and that's all very well defined. You can't accidentally start using stuff, using APIs or writing things that using APIs which aren't defined on the other platform which you're not using. You can't accidentally start depending upon semantics which aren't portable. And so that's all very well defined. That you can write your code and feel confident it's going to run cross-platform. Alternatively, you can write a module that targets one or the other of the virtual machines, in which case you can make use of modules which are compiled and defined specifically and target specifically one of those two virtual machines. In which case you can also interoperate with native code for that platform, right? So via Ceylon you can call directly to any Java SDK functionality. You import a piece of the Java SDK as a module. We expose, for example, the core is in a module we call Java Base, and another one Java Desktop, and by importing that module, you can make use of the Java SDK platform functionality. Or you can import a Java jar into the Ceylon module repository and start using that jar. Alternatively, you can, via Maven interop, you can depend upon a module that's in a Maven repository. Over in the JavaScript world, we have interop with native JavaScript, which is something that poses quite a challenge for statically typed languages, because if you want to call out to a native JavaScript API where there's no typing information available, you have a little bit of a problem, right? So there's two approaches you can take. One is to use a language construct called dynamic, which kind of suppresses some of the usual checks that the Ceylon type checker does, and lets you call stuff for which is dynamically typed, and the compiler won't complain. You'll get typing errors at runtime instead of at compile time. Or alternatively, you can write an interface, which we call a dynamic interface, which ascribes types to some JavaScript API in Ceylon, and then you can call this API as if you were calling any other Ceylon API, and your IDE will do auto completion, and you get errors if you call a function that's not defined. You can even partially ascribe types and leave some stuff dynamically typed. So usually, so sometimes when I, talk to people at Ceylon, their attitude is kind of, well, it's impossible that there could possibly be anything new about Ceylon. It's possible that it could possibly, have anything that's unique. Surely, there's umpteen languages for the JVM. Surely they've got it covered, right? So I thought I'd just, in this presentation, I'm just going to go quickly through several, things which are kind of unique. There's lots of unique things, but here are like three, all right? Because I don't have much time. So. First of all, we have a platform-neutral language module. This is quite different. We have this minimalist core thin language module that abstracts the differences between the platforms and exposes a common API. Its numeric types, integer and float, have semantics which are not platform-specific. In particular, they don't commit to a specific precision. Now, there's some kind of folklore surrounding the history of C which says that not committing to a specific precision, 64-bit, 32-bit, 16-bit, is a mistake. That I don't know particularly the history of how that turned out to cause problems in C, in the applications that C was intended for. It's kind of a different world, systems programming, to the kind of applications use VMs for. Also, there's a much bigger difference between 16-bit and 32-bit precision than there is between 64 and 53. So I don't kind of buy that whatever problems it caused in C are very relevant here. More importantly, I simply don't see how precision is possibly a legitimate concern of a static type system. There is nothing any static type system can do. Well, perhaps some dependent type systems, but not even them. There's nothing any static type system can do to protect you from numeric overflow. Numeric overflow is something which is always a runtime exception in essentially every programming language. Okay, let's not talk about dependent typing. That's not really even relevant when we're talking about at this level. So, why would you encode the precision if there's no reasoning that the type checker can possibly, no interesting reasoning that the type checker can possibly do about it? Why would you encode it into type system? Doesn't make sense. Along with the language module, we have this SDK, which provides cross-platform modules for the most core tasks, which we want to be portable across the two platforms: collections, internationalization, date times, JSON, HTML rendering, and obviously we're continuing to build that out. Obviously, there's a further purpose to all this. We want to shake out some of the legacy, mistakes, CRUD, things that have built up over 15 years that are in the Java SE platform, and hopefully arrive at something which is which is nicer, cleaner, more modern looking. A second thing that's unique on the JVM, well, not quite unique, there's another language called Gosu, which also has implemented this, that is support for fully reified generic types. And together with that, a really unique type-safe meta model for reflecting upon them. Okay, so in most languages, if you resort to reflection, or runtime reflection, and you say, you know, I want to get a reference to a method, an object representing this method, you get something of type method that doesn't encode statically anything about its return types, its parameter types, anything like that, and you're essentially into a whole world of dynamic typing. And so we kind of avoid, and runtime type exceptions. In Ceylon, when you take a reference to a method, you get back a method object that encodes the return type of the method, its parameter types, and that's because of a very cool aspect of how we model function types in Ceylon that we can abstract over function types, if that's possible. So we have fully reified types even on JS, where there's no reified types at all in the VM. So I've read often people arguing, well, type erasure, type argument erasure is not so bad. If you're starting to want to introspect the type of your generic, of your type arguments at runtime, then you're probably doing something wrong and non-type safe, and then wave hands here and essentially never really show why that might be true. I think that's not correct. I don't think there's any intellectual foundation for that point of view. I think it's clear that it's a backsplanation, that it's a post hoc justification for a decision which was made due to ease of implementation concerns, in fact. I think it's very clear that nobody would design a partially reified type system from scratch. If you're starting from scratch, you either design a type system where types are not reified at all, like ML, Haskell, etc., right? And you don't have reflection, you don't have runtime metaprogramming. Or you design a type system where all types are fully reified, like C# or whatever, and you have full runtime metaprogramming. If you're starting from scratch, that's what you do. So what we have in Java today is, it's a little bit of a kludge that results from concerns about implementation that perhaps were relevant 10 years ago, 10 years ago, I think. I would argue very strongly that generic type argument erasure is not okay if you also allow typecast to generic types. In Java, I can take a list of string and I can typecast it to list of integer, and the compiler will let me do it because it's a typecast. I've suppressed the type. I've suppressed the type checking. The runtime will let me do it because type arguments are erased. So nobody will ever complain at any point about something I did that's completely unsound, right? So the combination of those two features, those two characteristics of the type system, just is broken. What this all amounts to, fully reified types, is an awesome facility for framework developers. Finally, perhaps the most unique thing about Ceylon, and the thing which really people who first learn the language really sit down and go, huh, right, is support for first-class union intersection types. They're there because they form the foundation of a couple of other super awesome features, flow-sensitive typing and unambiguous type inference. That's how they ended up in the language. Since then, we've discovered that, to our surprise, that they just turn out to be so useful, right? To the extent that, I can't imagine why anyone would design a language with subtyping without first-class union intersection types anymore. The most famous, thing, the most famous immediate upfront thing is union types provide the most elegant solution to the problem of null in any of the modern languages. You see in all of the modern languages these days, even in Java 8, you see them all growing this option class, right? Which is designed to provide, some kind of null safety. In some languages it does, in other languages, well, not really, because your reference to your option might be null anyway. That's one solution, but it comes with a lot of problems, right? It means all these option wrapper objects, lying around. If I have an array of, or a list of 1,000 items, one of which is null, then I need 999 little option wrapper objects, which just exist to, encode the possibility of null. And, I don't think that's very good. So we have a different solution, which we'll see in a second. Essentially, union types get us to a point where we can use exceptions relatively less often than in other languages. We have exceptions in Ceylon. I think exceptions are good, are a very useful thing. They are a hole in the type system, all right? There are cases in Java where we use exceptions where I think that it is better to use a type safe to encode the condition in a type-safe way instead. So in Ceylon, there's nothing like null pointer exception. There's no array index out of bounds exception. These are things which are encoded into, these are conditions which are coded into the type system and which the type checker is able to reason about and help you find bugs. We will see how this changes basic idioms in the language. All right, so rest of my presentation. Oh, there's one more thing. 4 unique things. All right, function and tuple types. So there's a single, so in Ceylon there's a single class tuple written in Ceylon. It's an ordinary class. You can write tuple yourself and it has all the same characteristics, right? That abstracts over tuples of whatever length, right? It's possible to write this in Ceylon, and it works well. And then there's a single interface callable which abstracts over functions of any arity, of any parameter list length. Right? So who remembers how in mathematics, if I go into mathematics from a perspective of building up mathematics from sets and elementhood, who remembers how you define the notion of a function in mathematics?
X is equal to blah, where X is some value given some.
Right, but I'm starting, all I've got is sets and elementhood, right? So the first thing I build is ordered pairs, right? From ordered pair, in terms of ordered pairs and sets, what's the definition of function in mathematics? Right. It's a set of ordered pairs. Okay, that's how we define a function. It's a set of ordered pairs. X, Y, X, Y. Right? How do we define a function with multiple parameters? What do you imagine? No, but close. It's a set of ordered pairs where one of the elements, the first element of the pair, is a tuple. Okay, so close, right? So how do programming languages define this? Well, there's lots of different ways. But in Ceylon, we define it like mathematics. Callable is an interface. It has its return type, and it has a tuple type that encodes the parameter types. And that works. And now we can abstract over functions of arbitrary arity, and that opens up a bunch of stuff. It also means that we don't have to do any of these kludgy solutions that you'll find in other languages. We don't have primitively defined function types or tuple types in our language spec. They're just classes, an interface. There's no explosion of single method interfaces like what we see in Java 8, where we have all kinds of different interfaces with funky names for representing different arity and different types of functions. There's no F1, F2, F3, F4, F5 up to F22 like we see in quite a number of recent languages. Several recent languages have gone this path of 22 different interfaces to represent function types and this arbitrary top limit where for some reason we can have functions with 22 parameters but not with 23. Abstraction over function types actually enables some pretty cool stuff. We can have type-safe interceptors, type-safe proxies, more flexible APIs for things like promises, the meta model. All these things are actually things that you would only really expect to find in dynamic languages, or actually the kind of thing where you find the ability to, for example, spread a list over the parameters of a function. That's something you expect to find in a dynamic language. Something you can do in Ceylon because the tuple type that represents the parameter list of the function has to be the tuple you pass has to be assignable, right? So spread is an operation which is done in Ceylon in a totally type-safe way. So I just want to make a quick observation, which is that we arrived at some of these powerful and useful constructs not by thinking about the problems we wanted to solve necessarily up front, but by pursuing elegant definitions of things, right? How can we define this in an elegant way in the language spec? And the practical applications turn out to flow from those definitions. So the point about that is that big design up front doesn't suck all the time. It can actually be, starting with design, starting with a specification can be a good way in certain kind of problems, especially for something like programming language design, where you want very strong semantics, where you want something that's semantically very strong. All right, so let's see some code. So I'm going to go through and show a couple of idioms. I said that taking this different approach to exceptions to null and stuff changes the way you have to write some kind of thing. So obviously I'm not going to be able to show big, crazy, cool stuff you can write in Ceylon because it doesn't fit on my slides. I'm going to show little idioms, little everyday things, and how they get changed by a language which is more type safe. So let's consider, this is a contrived example. I promise it represents stuff that's real. It's a contrived example. But let's say I've got a function that returns, person. It might return org, or it might not be able to return a value. Let's suppose, for the sake of argument, that person and org have no interesting common supertype, right? So in Java, what would I do? Well, I'd have to make it return object. Returning null from API functions, sometimes it's okay, but because the API doesn't encode statically, doesn't give the compiler any way to warn the user that they need to accommodate the possibility of null, right? Very often we choose to throw in an exception in the null case, in the nothing case. So I might define it like that. Maybe I might just say object. The point is that then when I'm on my caller side, when I have to handle this, well, I have to kind of, have maybe a try catch, whatever. I call the function. I kind of test its, if it's an instance of this, if it's an instance of this. The irony here is that there's very few legitimate uses for instance of that aren't immediately followed by a typecast to the tested type. And yet every language on earth forces me to explicitly write that in, which is just kind of, really stupid from a why does the compiler throw away that information perspective. And there's nothing the compiler can really tell me to warn me that I forgot to handle a possible case, a possible outcome. There's nothing, if this function over here starts returning something else, it can just do it and all clients break, but not in a way that the infrastructure that the compiler can warn us. So here's how we write this in Ceylon. We use a union type. We don't use exceptions, so let's encode this case of not found with a class, not found, right? And so it returns org or person or not found. What are the common supertypes of a union type like that? What are the supertypes of that type? Every type which is a supertype of each of them. Okay, so every type which is a supertype of org and of person and of not found is a supertype of org or person or not found. Okay, that's implicit. What are the subtypes of that type? Yes, any type which is a subtype of any of those, right? So the union of the subtypes of org with the subtypes of person with the subtypes of not found. Right? Now we can handle the outcome of this with a switch, right? I can say case is org, case is person, or case is org or person. The compiler warns me if I forget to leave off this, it'll give me an error saying, your cases don't cover the switch type, right? They don't handle all of the possibilities. It'll tell me if the cases are overlapping. I won't have to do any typecast in here because the compiler automatically narrows to org or person or to not found or whatever it is. So a feature called flow sensitive typing. And I have something that's just much more, how can I say it, robust. Right? If this function starts to return some new kind of thing, all the callers break and get an error. And we have to go back and decide what we want to do with the new case. Okay, so that was a contrived example. Let's look at a real example, the first one, right? Retrieving an item from a map, all right? Map is an interface which has a get operation, right? What does it return? Well, it might return an item, right, given a key, or it might not find something, all right? So we'll say, you know, its return type is item question mark. This item question mark means, literally, null or item. So let's, at risk of losing some time, let's go and see a little bit more about null. So I'll create a Ceylon project over here. I'm not going to bother creating a module. I'll just do a silly something in a default module. What? So, you know, let's just start off with our little hello world program, you know. All right, so.
Gavin, what tooling are you using here? What is it?
Eclipse. Ceylon IDE.
Do you have IntelliJ plugins?
Not yet. Well, they've started work on one, but it's not ready for release yet. It's one of the things we, you know, want to look at this coming year. All right. So, you know, hello world. Wow. So, I have here in Ceylon an object called process, which has the arguments, which are the command line arguments, right? So, you know, let's get the first one. Arg here, right? So, and then over here we'll make use of it, right? We'll go, you know, we'll try to say hello arg, right? And oh shit, an error. String question mark is not assignable to string. Right? So what does that string question mark mean? Well, let's wait. Let's just make that type explicit there. We were using type inference. So it's string question mark. Okay, so that's the type of arg. So we know where that's coming from now. So let's see what that question mark means. It's what I just told you. It means null or string. So what this is saying is that this plus operator expects a null or string. Let's see what plus means, right? Plus actually means, you know, I'm just going to tell you what it means. It means plus, right? So that's just syntax sugar. Plus it's just syntax sugar as well for the operation plus. This is declared on well, it's written on string, but it's declared on an interface called summable, right? So you can implement that interface in your own classes. So over here, you know, we have this operation plus, which is expecting another string, and I'm trying to pass it a null or a string. Obviously, that's not well typed, right? Because nulls are, well, let's see why it's not well typed, right? So let's, you know, it's this null thing is, you know, probably bothering. What the hell is this? All right, well, let's go over and have a look. So it's a class, right? It's a class with one instance, this object null. Okay, so null's a class, has one instance, it's an object. It extends something called anything. So what's this? It says the abstract supertype of all types. A value of anything might be a object or it might be the null value, right? So we can see here, down here, this is an enumerated type, right? It's a sum type. Okay, so there are two subclasses of anything, object and null, and they are disjoint, right? So we know something that's a null can't be an object, something that's an object can't be a null. So over here, off of null, you know, we have, well, just the object null is the only thing that descends from there, and over here, from object, well, it's the whole universe that descends from here, right? So back over here, we can see now that it's, obviously null isn't assignable to string because string is an object, right? So it's everything, essentially, so it's integer, so it's, they're all objects, right? All right, so how do we narrow this from null or string to string so that I can do it? Well, I'm going to use a type assertion. So I'm going to use this thing, if assert exists, right? So this is an assertion. It says arg exists, right? And now arg has a type string. You're like, oh God, Ceylon's got all these special purposey things. What? Bigger. The text. Huh. Because in Yosemite they changed the... Well, no, they didn't change that font. I don't know. Oh, it's because my screen resolution's higher today. Can everybody read that? Okay. So, well, I'm going to tell you what exists means. Exists means is object. It's a type assertion, the closest thing Ceylon has to a typecast, right? So it just means is object. And now you're like, well, how did you arrive? If I just typecast it to object, how do we arrive at arg having the type string? All right. Well, we already knew that this was of type null. Well, this was type string question mark. All right. That's information we already have. Compiler's not going to throw away that information. So now we know it's object and string question mark. Those pointy brackets are just parentheses. They're in the type expression, right? So object and string question mark. We know what this means. Expand type abbreviation. We know what that means, right? Intersection distributes over union. Okay. So what I just wrote is equivalent of that. Now I have object and null. We just saw that object and null are disjoint types. That is to say, there is no value which is an instance of both object and of null. So what type is object and null? I thought I heard the right answer.
It's object.
No. Nothing. It's the bottom type. Okay. It's the type which has no values. Okay. Just called the bottom type in type theory. Okay, so it's the type with no values. It's the empty set, all right? You need to change, in Ceylon, you need to change your perspective to thinking about types as sets of values, right? So nothing is the empty set, right? So this is nothing. What type is object and string? Of course, string descends from object. So that is that. What type is the union of the empty set with a set? That's it. And that's how we arrive at arg having the type string. Compiler does all that reasoning exactly as I just demonstrated it to you. And that's just bread and butter. The compiler is very clever at reasoning about disjointness, about unions, intersections, and all that stuff, and can just slice through that stuff very quickly. Much more importantly than the fact that the compiler can reason about it is that for programmers, sets are very, very easy, very simple constructs to reason about. Nobody ever in high school mathematics wanted around, oh man, the set theory stuff's got me freaked out. Set theory is just intuitive and easy, right? And it's and it's useful, right? It's to me, it's foundational stuff, right? So for a compiler to not do this kind of reasoning to me is very strange. All right. Time. Okay. As usual, I'm way over time. What about if we know that get can't return null because of some constraint of our algorithm, some invariant of our algorithm? We've done something that ensured that something can't be null. This is a general problem. What if we know something about the type of something that the static type checker itself isn't able, with the rules of reasoning that it has, it isn't able to determine that? Well, that's the case where we use a type assertions, right? In Ceylon, we don't hide them in this little paren syntax. We put them up front because that's exactly the kind of things you want to document about your algorithm and that you want to be able to, attach good messages to and stuff like that. So for example, a stupid, example, right? Let's say I check that name is in the keys of the map, and then I know that obviously that map of name, these brackets are just syntax sugar for .get, okay, the .get operation we saw before. Then we know that this can't evaluate to null, so we can safely do an assertion and go on and do whatever we like, okay? That's fine, but obviously the point of using a static type system is we want to avoid as much as possible doing type assertions, right? We want to avoid that. What that means is that we need to start adjusting some of the ways we go about things, and we might want to do things in one step instead of two. In this case, we want to say if exist time zone equals map of name, so we do the lookup and then we assert that and then see if it exists and then do what rather than doing it 2 steps there. A little bit contrived here. Let's see how it really affects real cases by looking at iteration of lists. Okay, so iteration over lists. All right, what's the most basic thing that I learned when I was like probably 6 years old or something on my Commodore 64, on the second page of my programming book, was how to write, for I equals 1 to 100, hello, right? The most basic thing in programming, right? A for loop with, on indexes, right? So if we wanted to write that in Ceylon, we'd say for index in 0 : names.size, we have a freaking assertion because we know it's not going to be null. Let's say we have a list of strings here, so we know its elements aren't null. And then, well, that's nasty, right? So the very basic thing from page 2 of my programming book from when I was 6 years old breaks in Ceylon, right? Or is clumsy in Ceylon. So we have to take a different approach. If we want to iterate over indexes, then we go and call this, there's an operation called indexed on streams, an attribute of which returns a stream of entries, right? And then we have this little destructuring syntax to map the key and item of the entry onto 2 variables, and then I can go and do it that way, and that works. You're like, oh yeah, but that's not the only case for why I would want to iterate over indexes. Maybe I want to do a subrange, right? Well, again, then we need to use the subrange operator. This is just another syntax sugar for names span start comma length, measure, sorry, span comma length. What if I want to do, every nth, then I call a function called by of stream, right? So I have to start using these functions which apply operations to streams and using this for construct to iterate over things, right? Instead of using access by index.
What's the return type of index?
Of indexed is a stream of entries. Okay. Integer, in this case, because we're looking at a list, integer to string because they're names,
okay.
right?
And so
it's name
is just
that's just a little destructuring syntax. Okay. Syntax, yeah, it's nothing fundamental. That is actually. I'm going to go on. Okay. But I can answer more questions about that in a second if you like. Overloading. Got some bad news. Who doesn't love overloading? I got a function square root, right? I can take a float or I can take an int, returns a float in both cases. I don't want to have to think of 2 names for that function, right? Square root int, square root float. That's just sucky, right? It's nice to be able to just call them both square root, right? So I got some bad news. Ceylon doesn't allow overloading of any sort. Doesn't really work very well in an environment, in a program where the idioms use a lot of passing functions around. Because I can't take a reference to this function square root. If I take a reference to this function, well, which square root? If I just write square root, map square root, well, which square root? All right. So I'd have to think of some ugly ass syntax, I don't know, square root hash, I don't know, I don't even want to go there, right? So our better solution is just, well, we don't have overloading. You're like, well, that's not a solution. Well, it turns out we have a set of idioms that make overloading much less important. We have things like variadic parameters. We have defaulted parameters. We have union types. I can write this function square root as a function which returns float and accepts either a float or an integer, and I can switch on it, right? And say if it's a float, then return that. If it's an integer, return that. Okay, it's a little uglier. You know, it's a little more verbose than the version before, but it has a big advantage. I can take a reference to this function, and I get a function of type, function returning a float, accepting float, or integer. Right? So that's useful. I can pass that to map on a stream of floats and integers. You're like, yeah, but I see what you did there. You picked this because you knew that the return type is the same on both of it. What about square? Squaring an int returns an int, not a float. So yeah. Some cases you have to resort to generics. Okay. So square root of num, where num is either float or integer. We can still obtain a reference to this function, but we do have to explicitly specify what the type argument is, whether it's float or integer, because Ceylon doesn't support a thing called rank 2 polymorphism for those people in the audience who are interested in type theory, which is, I don't know how many people, probably not all of you. All right. It turns out that, look, I'm not going to lie. Not every case where you'd possibly want to use overloading can be accommodated by these tricks and patterns. Some cases can't be, and in those cases you have to go and think up a new name. And, happens. I want to talk about the relationship between unions at the type level and unions at the value level. So one of the things I found very interesting when I first saw Java's set interface was that it seemed to be missing the two most interesting operations of set. What are the basic operations you do on sets? Union intersection, right? Have you looked at Java's set interface recently? It doesn't have them. Where is that? Well, I try to write down what the correct signature for a union on set, and I almost succeeded, right? If Java would have something called lower bounded type parameters, then I would have been able to. That would look like, in Java syntax, it would look like, given a U that's a supertype of the element type of the set, and a set which is a set of those things, a set of something which extends, which is a subtype of those things, then I get a set of those things, right? This would work in Scala, because Scala has lower bounded type parameters. And then I could have a set of foo and a set of bar, and if I called set of foo union set of bar, and I explicitly specified a type over here, then I guess the compiler could sort of infer object as U, and it would sort of work, right? I would have to explicitly specify a type, but it would basically kind of work. In Ceylon, signature of this function is quite straightforward, right? Given a set of those, if I have a set of these, give me a set of those, and I return a set of things that are these or those, right? So union, the value level, corresponds to union at the type level. And then I have this set of foo and set of bar. In Ceylon, we actually have a syntax sugar, notice the theme, for writing x union y, which is the bar. But it just means that it will be exactly the same thing if I wrote x dot union y. And I get a set of foo and bar, but I wouldn't have to explicitly write in the type there. That type would be inferable because of a property of our type system called principal typing, right? Our types form a lattice, right? Give me any two types, I can form the union of them, which is the most precise supertype of the two types you've given me. That ability to form a most precise supertype doesn't exist in other languages with subtyping, which means that things like type inference, that ambiguities creep into type inference and stuff like that. Intersection. So I tried for a while to write down set.intersection. Failed. I don't think it's possible. You know, over at union over here, I should say, you know, it's possible to write down. It's probably possible to write down a decent union in Java using a static method. I think intersection. I don't think you can even do it with a static method. You know, I tried a bunch of things and just I couldn't make it work out. Right? In Ceylon again, intersection has an intuitive, easy to write down signature. Again, the right type pops out automatically. You're like, okay, well, I don't write much code with sets. So this is all a bit, you know, like, you know, it's a nice intellectual exercise, but it's not very useful. Yeah?
What does the intersection of these and those even mean? I mean,
it means something is a these and those if it's a these and a those, right?
okay, so they would have to be union types themselves?
It would have to be a class which implements both these and those, which extends these and implements those or whatever, right? Yep. Okay. So the supertypes of these and those is every type which is a supertype of these and every type which is a supertype of those. Yes. And the subtypes are every type which is a subtype of both of them. So you're like, no, you know, this is all a bit intellectual, right? Well, no. One of the most useful functions ever coalesce. Takes a stream of values, some of which may be null, and gets rid of the nulls from them. That's super useful in a type system which has type nulls. Super useful. So in Ceylon, what's the signature of this? Well, first I better explain to you, we have a syntax sugar, notice the theme, for streams. Streams are used everywhere in Ceylon, right? So streams is a basic construct, you know. So we have a syntax sugar. This T with a star in braces means iterable of T. Okay, that's just what it means. We'll see what we'll see what the difference between the star and the plus is in a second. And so, you know, I have a function which takes a stream of elements, and what it returns is a stream of things which are element and object. That's how easy it is to say all the elements without the null elements, right? Because we know object and null are disjoint. And the compiler, if I you know, pass in string question mark, the compiler will automatically do all its wonderful stuff and simplify string and object to string question mark and object to string like we already just saw over there. Here, if you're wondering what this syntax is, this is a comprehension. All right? So I'm not sure how many people have used a language with comprehensions before. Person? 2 people? Yeah, 3? Yeah. Okay. So quite a few dynamic languages have comprehensions. Haskell has comprehensions. It's a syntax that comes essentially from mathematics, right? So looks a lot like SQL, actually. So it's a very flexible syntax for performing transformations on streams. Okay. So, you know, over here, give me some strings and some nulls, and, you know, I get back this type, coalesce them, and I get back a stream of strings. I would not have to write these types in. I'm writing them in so you can see what their types are, okay? But they can be inferred. Finally, this is my last little section, because I've talked for much too long already. Max. This is a problem that bothered me for years, I would say. It took me like 3 years to figure this one out, right? I didn't figure it out, somebody else came up with a solution, Evo. So, well, we came with it together. The max function. Remember, we don't like throwing exceptions to handle the empty, the nothing case, right? So what's the max of a stream of, let's say, floats or strings or whatever it is? What's the maximum? All right, it's the biggest int or string in the stream. What if the stream's empty? What's the max of no strings? So the max of no ints is worse. Null? Throw an exception? In Java, I'd probably throw an exception, right? I wouldn't like to return a null from max, right? That would be a little bit, I think people would expect that. So I'd probably throw an exception. But remember, we said we don't like throwing exceptions. So if I were to write it down in Ceylon, I guess I'd return null. I'd say a max of a stream of values, the values of some comparable type, and I return value or null. What if I have a stream that I know is not empty? Which is most of the time when I'm calling max, right? Really pain in the ass that the compiler is going to force me to handle that case of null. All right, well, okay. Well, what I could do is I could write a max non-empty function which takes a non-empty stream. And it returns me a non-null value. And now I've got two max functions. This is the best programming language on earth. It's unacceptable, right? It's just unacceptable. So this doesn't let us abstract. All right. So what did we do? We added a second type parameter to iterable. Let's go and have a quick look. So we have absent here, right? We have element, that's the one you're expecting to see, and then we have absent, which is something else, right? Absent has a very funny looking type constraint on it. Absent satisfies null. What could that possibly mean? What are the possible arguments to absent? Null and nothing. Perfect. You guys are the best group so far. I heard nothing simultaneously like from 3 or 4 different people. And what would that mean? Well, let's go see what it means. Let's look at first and look at its return type. Its return type is absent or element. So in the case where absent is null, its return type is, say element is string, then its return type is string question mark, is maybe string, right? If absent is nothing, then its return type is just string, right? So absent encodes the emptiness or non-emptiness of the stream, right? Using a trick. Sure, it's a trick. I'll admit it's a trick. And lets us, have defined operations like first or like max, which return a maybe type or a non-optional type automatically, right? So if I take max of of an empty stream, I get null back. The type that would be inferred, by the way. I'm writing it in for you guys. If I take max of a non-empty stream, I get a string back, non-null. If I take a max of a stream which I'm not sure is it empty or not, I get maybe string back. Again, inferable. So the type checker is able to reason about emptiness, non-emptiness. I'm going to stop there to give Steph a go.
Hello, my name is Stéphane, and I'm working for Red Hat, and I'm going to talk about the ecosystem that's around Ceylon and what you can do and what are the projects that are popping up, and then I'll conclude with a bit about the future of Ceylon, the programming language. So I mostly I've been working on Ceylon for 3 years now. I mostly work on the JVM compiler. So if you followed Gavin's talk, you know we have 2 compilers, one for JavaScript, one for the JVM. I also work on Herd, which is our module repository, which I'll present later on. And I generally do plumbing work between all the projects and trying to make everything compile at least. As soon as it compiles, we ship it, like everyone, right? So I'll be very brief in my intro because Gavin has already talked a lot about the language and what we're trying to do. You've seen that it's very inspired by Java and C#, at least the syntax. It's meant to be easy to learn. It's meant to be something that is intuitive to learn and to read and to write. There are some features that you will find in other languages. Some are quite unique, like verified generics, which means being able to access the type parameter values at runtime. The module system, the meta model, which is something that is like reflection, but then also incorporates the idea of modules, so you can use reflection to access the list of modules that are running, what packages they have, which types are defined in these packages, etc. Runs on the browser, runs on Node.js, runs on the JVM, runs on Android as well, and it's fully interoperable with Java and JavaScript, which means that you can use any library defined in Java, whether it's a Maven jar, the JDK, or any other jar, and you can use any code defined in JavaScript as well. So I'll start with the Ceylon IDE. You've seen this already. This was something started by David, a member of the community, and Gavin. It's integrated with JDT, which is the Java mode for Eclipse. So it means that you can edit Java files as part of your Ceylon modules as well. They will be compiled in the same pass. Obviously, it supports everything that the rest supports, which is compilation to the JVM, to JavaScript, lots of quick fixes. It supports the module system directly from the IDE, so you don't need to go to install another plugin to download the dependencies of your modules, or to publish to a remote repo and to fetch all the dependencies. And it's definitely production ready. It's something that is on par with the Java plugin. It has tons of features. It's very solid. It's very polished. We have another IDE plugin for IntelliJ, which was started by Bastien and Mattia from the community. It supports a number of things already, which is most of the hard work has been done: syntax scoring, compilation, navigation work. And I guess it supports running as well, but it's not completely done. It lacks the quick fixes and integration with the model of IntelliJ. So if you want to give it a try, it will get you started, and if you want to contribute to it, then you can start adding quick fixes, and it's something that is growing up. It's not finished yet, but it's growing up nicely. So I'll start with a first demo of what you can do with it. For this, I will switch to the IDE. I'll do a demo that I did at Java 1 last year, which is a two-sided demo where I'm going to have two modules. One module is going to run on the browser. It's going to open a WebSocket to a second module that is running on the server on the JVM. And that module is going to read data from a database and send it to the client of the WebSocket. So I'm going to show you first the server. Is this big enough, or should I make it bigger? Big enough? Yeah? Okay. So this is the server module. It's defined in a project. It has a module descriptor. This is the module descriptor. It says this is the name of the module. It's called server. The version is 1. And then it has a number of imports, which is all the modules that I import. So if you do this in Maven, for instance, this is equivalent of the POM, except it's in the language itself. And the IDE supports it and will fetch all these module dependencies. The first 4 are from the SDK. So the database module, the net module, the input, output, and JSON modules come from the Ceylon SDK. We have an SDK which allows you to use the same modules on the client and the server, which is something you could not be able to do if you were importing the JDK, for instance, because it's not available on JavaScript. The JDK is here. When I say import java.base, I'm using in Ceylon we're using the names of the modules that will be used the day that Java supports modules. So if you follow the story around modularity in Java, it was already planned for Java 7. They had this project called Jigsaw, which is the splitting up of the JDK into modules. And the list of modules has been actually pretty much set in stone since Java 7 already, and it's known, and we've followed this pattern so that when you import Java, you don't get the whole JDK with lots of stuff that you would never use, like AWT. So you can see here with completion that it will show you the number of modules defined in the JDK, and the most important one is java.base, which is practically everything that you would use. It has Java lang, Java util, etc. Then next I have another module, which is the Postgres module. This is a jar that comes straight out of Maven, so I imported it in my repository. We support Maven modules as well. You can import them. So this is the JDBC driver for Postgres database. So let's see my function here. I have a function here called run, which is by convention the main entry point if you don't want to override it. I make it shared so that it's visible outside the module. And you can notice that it's not defined in a class. So in Ceylon we support defining functions and values at the top level, which means that they belong to a package. The first thing I do is get a SQL object, which is a function, another function at the top level defined here. What I will do here is I instantiate a Postgres simple data source. This is a call to the constructor. I don't need to use new in Ceylon, the new keyword. In Ceylon, the classes are functions, because what is a constructor in the end, if you think about it? It's a function that takes a number of parameters that you pass to the constructor, returns a new instance. So in Ceylon, constructors are and classes are functions. So invoke this constructor. I get something that the type sister will infer as being of type Postgres data source, and then I set a number of properties. So you can see here what I'm doing is I'm calling set server name, set database name, set user, set password. Which you have to remember, all of this is actually coming from a Java library, right? And in Java you have two things. You have fields, and then you have Java bean properties. They are not exactly the same. They were never integrated, and from the outside, the calling convention is different. In Ceylon, we unified them, and we made it so that from the outside, whether the attribute is defined as a constant or as a virtual attribute with a getter and setter, you don't have to care about this. So from the outside, you can change how you implement it, and then from the inside, you have a slightly different syntax to define them. So I set all these Java bean properties, and then I return a new instance of SQL, which is defined in the SDK. And SQL expects a function as parameter, which is a function which is a thunk, takes no parameters, and returns a new connection every time. So I send it a function, I give it a lambda, which takes no parameters and returns a new connection every time. So I get my SQL connection. I'm back to my run function. I have my SQL connection. What I'm going to do here is create a new WebSocket server. So I call new server, which is something that comes from the Ceylon.net module. It has an HTTP client, an HTTP server, and the server underneath is using Undertow, which is the same server that is used by Wildfly. Thank you. So I start a new server, and I specify that I want a WebSocket endpoint. And here, when I'm using curly braces with method invocation, it means I can pass parameters by name. So we support default parameter values in Ceylon. And for instance, this constructor WebSocket endpoint takes a number of parameters, a matcher for the path for which it is supposed to be installed, and then a number of callbacks on open, on close, on error, etc. And all of these are optional. I only want to provide one, so I will just, instead of specifying a default value myself for them all, I will say, okay, the path is this, and the unopened callback is this lambda here. So that's a lot shorter. So I define my function here, my lambda, which I pass it, and this function is going to get called every time somebody opens a WebSocket to this URL. And what I'm going to do when I get a new WebSocket, I'm going to call the read SQL function here, which is a very simple function. Takes a SQL connection, and a callback, which will expect a name, a version, and downloads. So I'm connecting to the database of the module repository, which I'll show you later on. So I get the list of all the modules defined in this database. I'm going to run a bit of SQL, which is going to select the name, etc., and then do a limit. I'm going to iterate over each of these rows. And here you can see that in the for, we also have type inference. We don't need to define the type of the variable we're going to use to iterate everything. This is inferred by looking on the right-hand side at what's in there and what we are going to iterate. So we know rows is of type select result. So we know that each element in there is going to be of type map from string to object. So type inference in Ceylon is something that looks on the right-hand side to determine what is going on the left-hand side, which is different from Java, where Java type inference actually looks on the left-hand side, which means that you need to repeat a lot of things. So I iterate over each of these rows, and then I'm going to use the flow typing with assertion to make sure that I do have a name of type string, a version of type string again, downloads of type integer. And then I'm going to call the callback I got as parameters with these values. Here, for the row, again, this is syntactic sugar for calling the get method, right? So I go back here, and what is the callback I'm going to pass? I'm going to pass this callback here, which takes a name, version, and number of downloads. I'm going to create a new JSON object, which is something defined in the SDK. The interesting bit about the JSON object is that it uses union types, which you've seen earlier, and you can see that in Ceylon, in JSON, this is something that makes a lot of sense to use union types, because the JSON norm specifies the values that are valid as types in JSON, and those values are a number of values. You can have strings, integers, floats, booleans, arrays, objects, and null. And that's about it. You cannot have anything else. So it makes sense to have a union type rather than what you would do in Java, which is say, well, it's a Java lang object because it's the only common supertype of these. So we have a JSON object, and you know, you can think that this is not very useful, but you know, here I have a name, and I'm going to put it. I can put a string in a JSON object. I can put a number. I can put a boolean. But for instance, if I wanted to put a SQL connection, then I would get an error, because it's not one of those values allowed by JSON, right? If you had gone with the Java lang object in Java, the compiler would not be able to tell you this is not a valid JSON value, right? If you had just limited yourself to the common supertype. So because we have more expressivity with union types, then we are able to detect errors such as these. So I create a JSON object that I'm going to send to the client. I print something on the console. So here you can see that we have a string interpolation in Ceylon. The way you do it is that to escape the string, then you use double backtick, and then you can insert any expression inside the string. And then I send the JSON as pretty printed to the client over the WebSocket, and I sleep for 500 milliseconds, so you can see on the client things appear. So I have my server. It connects to the database, gets every row, serializes it to JSON, sends it on the WebSocket, and then I start my server on this port. So let me run this function here, right? And now I'm going to show you the client. Is it here? There. So the client module is very simple. I only import a single module from the SDK, the module that deals with JSON. The nice thing about having an SDK that is portable is that once you've learned how to use the SDK, you can use it on the client and on the server. If you've ever dealt with collections, if you've ever written JavaScript code, you've surely noticed that there are no collections in JavaScript. You have array, and that's it. You don't have sets, maps. You don't have any of those nice things. And you know, I've been working in Java for over 15 years now, and I know the JDK pretty well. So it takes a lot of time to know all that an SDK has to offer, right? So you know the idioms, you know the types, you know the packages, you know how they fit together, how they integrate, and that knowledge is worth something. The minute you switch to JavaScript, you have to learn the new idioms, you have to learn the new collections, you have to learn which packages provide what you need. And you know, the great thing about having a single language to write on both platforms and a single set of modules that you can use both on the client and the server is that you can reuse your knowledge. Once you've learned how to deal with collections on the back end, you can use them on the front end, and then you don't need to learn a new API. Same with JSON. So what we do here, I showed you how we deal with interop in Java. It's pretty, you know, fluent. It's something that integrates well with the language because everything in Java is well typed. It's statically typed. In JavaScript, it's a lot different because you don't get types from JavaScript. You cannot ask the JavaScript what is the type of window, what is the type of WebSocket or jQuery. It doesn't know this at compile time. So what we do in Ceylon for interop is that we let you unplug the type checker by entering a dynamic block. If you're on JavaScript, you can enter a dynamic block, and within this block, the things that the type checker knows about, it will type check, it will give you errors, etc. if you do it wrong. The things that it doesn't know about, then it will just let you go on, and you will see at runtime if it runs or not. Hopefully with meaningful error messages that we insert. So here I'm allowed to call the WebSocket constructor, which is something provided by the browser. And I can assign it to a variable of type dynamic, again, because I don't know its type. I can call jQuery directly from the jQuery.js, get a reference to a target, and then I can create a lambda which takes a dynamic event and assign it to the onMessage callback of the socket. So this is, you know, pretty much how you deal with new messages in WebSockets in JavaScript. What I'm going to do is I get the data from the WebSocket, and then I parse it as JSON. So this is from the SDK. I make sure that I have an object and not an array or an integer, etc. And then I make sure that I have a name, a version, a downloads, and then I'm going to call jQuery and create a new element which will show the module with the version and the downloads, etc. So let me show you what this does here. I have a button. When I click it, it's going to call the server. It's going to read the database, serialize to JSON, send it to the client. The client is going to unserialize it, call jQuery to create a set of badges. And if we look back in the logs, we can see the string that we printed with string interpolation by printing every module as we send it to the client. So let me show you now how the JavaScript looks like, because you may wonder, okay, so what is the amount of manual plumbing required to make this work on the client? And it's fairly simple. We have some standard things in there, like the content type, the title, the bootstrap, and a little bit of CSS. I just import the jQuery script as is, the require.js script as is, which is the module system we use for JavaScript. It's fairly standard. Then I need to configure require.js by telling it that my modules are located here. And then I have a little bit of jQuery which says when the document is ready, invoke this thing. I'm going to use require.js, which is the module system, to load my module, client version 1. And when the module is ready, it's going to invoke this callback. You know, JavaScript is a bit callback hell. You know, you're probably used to this. And then I install a click handler on my button clicky here. I have a button here. When I click it, it's going to invoke this function. And this function, what it does is invoke the run method on the client module, right? This, let me kill this up. This run method on the client module. That's what it does. So you can see there's very little boilerplate in making this work on the client. So I've mentioned the SDK a bit already. And Gavin has mentioned this as well. What is worth noting is that the Ceylon distribution has only one module in there. When you download the zip or the IDE, you get only one module, which is the Ceylon.language module, which is the equivalent of Java-lang. It has the minimum set of things that you need to be able to run Ceylon. So it has all the all the basic types such as string, boolean, integer, float, character, byte. It's worth noting that Gavin has mentioned this, but it's worth really making sure that you understand this, that we don't have primitive types in Ceylon. Everything is an object. We don't have a hole in the type system to make room for int, float, etc. that you cannot use as generic type arguments, that you need special functions and special boxing and whatever. Everything is an object. This does not mean that underneath we don't use the proper primitives, especially when we compile to the JVM. And indeed, we do. We do use primitives every time that you would be able to use a primitive when you write code in Java yourself. We do use primitives, but we don't, make you mess up with that. We don't make you see all the kitchen of boxing and using primitives or not that is underneath. So you don't have to deal with this. We have interfaces for set, list, and map, but not implementations. We have a number of interfaces that define operators that you're allowed to override, such as summable for plus or correspondence for the get method, the square brackets that you've seen already. We have the type of functions, which is callable. We have apply, which allows you to invoke a function passing it a list of parameters. A little bit of information about the system, such as what is the backend, which is the version of the language we're running on, and the meta model, which allows you to inspect the modules and the programs and the types that are running. And that's it. You only get this thing. The rest is available online, downloaded by the tools, and the whole SDK is published on the module repo, which I will show you very soon. And you get this SDK as completely separated from the distribution. This is very interesting because it makes our download much smaller. You don't have 70 megs of download like you would get for the JDK, and you only download the modules you need. It also means that we can actually update the SDK between releases. So if we have a bug fix, for instance, we don't need to ship a whole new release for a bug fix in the collection module, because you can just get the new collection module the day after we made the release. So we have a number of modules in there. Some of them are cross backend, so multi backends. They work on both on JavaScript and the JVM. Some of them don't, such as the file module or the process module. You're obviously not allowed to run processes on the browser. So there's a lot of sense here. It's still growing. It's not complete yet. We hope to add new modules and finish those areas that lack, but it's growing pretty nicely. All right. Now I'm going to talk about the command line interface. How many of you use a terminal to work? All right, roughly half the room. This is Gavin never uses a terminal. Right. And does everything in the IDE, but myself, I have both. I have the IDE and then I have the terminal. I end up spending a lot of time in the terminal. And this is why we gave you a great language, a great SDK, a great IDE, and we also wanted to give you all the tools that you need to work in Ceylon, including a great command line interface as well. So initially we started like Java and with Ceylon C for compile, Ceylon for run, and then Ceylon D for doc, and then we ran out of letters and we had to add other names, exactly like in the JDK. You have a number of commands that start with Java and then a number that don't, like RMIX or JVisualVM, and it's really hard to actually know what's in there. And very often people are not even aware of the commands that the JDK ships with, like VisualVM. Lots of people don't even know that it ships with this. So we noticed that there's a lot better syntax, which is the one based on Git. Git, you get only one command, and then from there you can discover all the rest. You type git, and then you get all the list of subcommands it has, and that's the model we followed. Now we have one command called Ceylon, and you get completion, which will tell you all the subcommands that you have, like compile for compilation, doc for generating the API, run, etc. It has completion, it has contextual help, and you can discover all it has. It also supports plugins, which are commands that you can add after the fact, after the distribution, such as the build plugin, which I'm going to demo right now. I'm going to show you the command line we have in another module. We're here. So I have a module here which is going to use the SDK for net and JSON again. I'm going to say hello, and then I'm going to connect to GitHub to get the list of repositories in the Ceylon organization. I'm going to parse this as JSON. And again, you can see here union types again that make sense for JSON. I'm going to iterate each value. And again, if I have a JSON array and I iterate over it, I know that each element has to be of type string or Boolean or integer, etc. I'm going to make sure that I get objects and that the name and issues are defined. And I'm going to print the number, the name of each repo and each number of issues open. So how does this look like from the, we've seen how we run things from the IDE. So how does this look like from the command line? We have a single command. We get completion. We see that we can compile it. We can compile it for JavaScript. We support configuration as well for very much like in Git, where you can override the list of source files, etc. You can define this in the configuration for your user, for your project, etc. A number of things. So what we do here is that we're going to say compile, and then the name of the module, and that's it. We don't have to deal with the class path. We don't have to deal with dependencies. We don't have to deal with the list of files. You just tell it the name of the module. By convention, it will look them up in the source folder, and it compiles it. It finds all the source files defined for this module, and that's it. I don't have a build script here. This is the command line doing its thing. It knows how to deal with modules from the input, from the output, from dependencies, everything. And now I need to run it. And again, I just pass it the name of the module. I don't deal with the class path. I don't deal with dependencies. I don't deal with specifying the main method. Everything works with conventions. You can override everything, obviously, but you don't need to. So I mentioned Ceylon Build. Ceylon Build is a build system for Ceylon that was started by another member of the community, Loic. It's very inspired by Gradle. It lets you write your build in Ceylon. So for the same reason that I said it makes sense once you know an SDK and a language to be able to use it on the client and the server, then the same applies to writing it in your build. If you have to learn a new language to write your build, and the new SDK as well that goes with it, then this can be problematic. So you can write your build in Ceylon as well. Let me show you this. So by convention here, we have another source folder called build, in which we have a build module. This build module imports two things for this one. The build engine, which is all the annotations required to be able to define my build, and the tasks for Ceylon, which allow me to invoke the Ceylon compiler, the documentation generator, and etc. So let me show you what it looks like here. I'm going to do something very simple. I have a top-level attribute defining the name of the module I want to compile. Then I have a new goal, which is something I can invoke from the command line, so the equivalent of a task in end. It's just a function, compile. I'm going to say what I'm going to compile, and then I'm going to call the compile subcommand of the Ceylon command line. Let me show you how it looks like here. So I do Ceylon build. If I run it like this, it's going to tell me the number of goals. It says, okay, I have 2 goals, compile and publish. So I'm going to call compile. It says I'm going to compile, and then compiles it. It's worth noting that we don't ship with the subcommand Ceylon build. If you want to install it, then you say Ceylon plugin install Ceylon build 1.1.0, and then it will fetch it from the module repo, install it on your machine, and then you discover it and you have completion over it, etc. So this is pretty nice. Let's go back here. I've mentioned it already a few times, heard. This is the module repository that we wanted to give you. We wanted to be able to use it. We wanted to be able to give it to you. So it's a web application that allows you to publish modules online. One of the goals, strong goals from we had two strong goals. The first one is it has to be pretty, it has to be usable, it has to be something that everyone is able to use, and the other is it has to be free software, so you can actually use it yourself, download it, run it internally if you want, privately or publicly. It's the exact same software that we use. If you go to modules.ceylonlang.org, then you get the exact same thing running, and we give you all the tools required to be able to use Ceylon. Its web interface, it has a REST API that is used by the command line, by the IDE, by everything. It supports staging repositories, which is the area where you upload your modules and then they are checked by the system and you can check that they are proper and everything, and then you can publish them. Works with teams and permissions, etc. It's integrated with the IDE, the command line. It integrates also with GitHub. And there's a social aspect to it as well, so you can get RSS or atom flux of, what are the modules published by this guy or this company this month. You can follow the new versions that come out, and that's pretty useful. So let me show you what it looks like here. Right. So this is what it looks like when you're not logged in. You can look at categories of modules. So for instance, we have the SDK. You can see the number of modules defined here, some of which are compiled for JavaScript, some of which are not. So for instance, collections. You can see documentation directly from here. Number of downloads. This is running on my machine, so obviously the numbers are a bit off. You can comment, you can rate it, you can view all the versions that are available. You can view the documentation directly from here. We have very nice API documentation as well, with support for shortcuts such as being able to search, etc. So if I want, for instance, hash set, I have a number of choices. I can use my keyboard to navigate in the documentation. That's very useful. So what we're going to do here is I'm going to get a little bit of help and see how I can publish my module. I want to publish my module. I already have an account. I already claimed my project, which is a phase where you use the system itself to be able to ask, okay, give me permission to publish this module. I'm this guy, and we're going to check that you should be allowed to publish this module, and you're not going to, put malware and stuff. So to upload the module, I just log in. I create a new upload. Again, big button, it's very easy. It tells me how I can upload. So it tells me what are the flags from the command line that I need to run to upload from the command line. Now you can do it in the IDE as well, but that's not nearly as funny, so I'm going to show you how to do it from the command line. I can upload a zip as well. But I'm going to add a twist. I'm going to use the build that I have to ask me where I'm going to publish it. So what we've seen earlier in the build script is something that is fairly static. It does the same thing for everyone. What I'm going to do here is add a new goal, which is publish, which will ask me what is my username, what is my URL, and every user has a different URL for the staging repo. Every user has a different username, and so it doesn't make sense to encode this in the build. It makes sense to have some bit of code that will ask you for this, possibly store it in a file for the next time. And that's where it makes sense to have code in your build that is going to be a little bit more interactive. So I'm going to ask the user for the URLs, and then I'm going to compile and document the module directly to this repo. So again, the tools know how to deal with remote repositories, including publishing directly to them. So let's see how this goes. From the command line here, I have Ceylon build publish, and it's going to ask me, what's the URL? What's my username? What's the most secret password on internet? And it's going to You see, it compiles it to here. It generated the documentation directly there. Now I can go back here and hit reload. And I see that there is a module. I have a warning. Why do I have a warning? Because I haven't compiled it for JavaScript, so it's only available for the JVM. But that, fair enough. It tells me the members that are defined in there. I have only one function. I don't have any scripts. I can check, that all the files are there. I can check the documentation and see that everything is well. And then I just publish it. Let's see where it is, and I can see it here. Published 4 seconds ago. That's where it is. That's as simple as it is to publish things on Herd. Right. So it uses this. This is. I can show you. If you go to modules.ceylonlang.org, it's the exact same thing. That we use for production for publishing the SDK and publishing the equivalent, if you will, of Maven Central. All the Ceylon open source software is there. And you can also get this thing, it's free software, use it in your company privately for your private projects, or create an alternate public repo, whatever. We give you all the tools. It's up to you to see what you do with them. The last demo I have of the ecosystem is of Vertex and Kyla. Gavin has already asked how many of you know Vertex. It's a clone of Node.js, the web server and framework architecture of Node.js, but then for the JVM, which means that you can use any language you want, Java, Ceylon, Groovy, whatever, to write your code in the Node.js architecture. And you can use all the libraries that are available on the JVM, which is quite a lot of libraries, and it's very useful. It got started. The integration with Ceylon got started by Julien, another member of the community who's now working for Red Hat on both Vertex and Ceylon and the integration between the two. It consists in a number of things, a number of pieces to the puzzle, the first one of which is the promise module that we have in the SDK. It's an implementation of the A+ promise spec that some of you may know, that is available in many languages. It's very much like futures, where you define callbacks and what I want a reference to something that may be computed later. Then you say, okay, give me the value now, and then it blocks, or register a callback for when the value is available, and you can chain everything. It's a model for asynchronous programming. The second block is the integration with Vertex, which allows you to both invoke and start Vertex from Ceylon and write your verticals, which is the bits and pieces that you deploy on Vertex in Ceylon itself. Vertex will pick them up, compile them, and install them properly. And then it also consists in Kyla, which is a web framework for Ceylon. That is both a web framework and a model view model module, very much like AngularJS. I have a little bit of time to show you a quick demo of Kyla that I have here. Right. So I have a Kyla using module. I just how do I use this framework? I just import this module. That's it. And then I will, the way it works in Kyla is that you defined a controller which extends a handler. You have annotations here that say, okay, this is something that works for any path. This is a URL template. Route is an annotation. Maybe you haven't noticed, but we have a number like goal earlier for the build. We don't need the @ sign for annotations in Ceylon. And indeed, shared and actual, default, etc., they're all annotations, they're not keywords. So I annotate my controller, and then I have an invoke method that will get called by the framework whenever somebody connects to my web server. What I do here in this thing, I'm going to get the Vertex instance running behind the scenes and create a new asynchronous HTTP client to the Chuck Norris database. I'm going to use a get method, get request here, and then I'm going to return a response that is a composition of several promises. I'm going to make sure that I'm going to return a promise of a response that is going to be a chain of the response of the HTTP client here, with something that will parse the body of the response as JSON, and then invoke a transformation on it, which is here a local function, which takes a JSON object and returns a response. That's the final bit of the asynchronous processing. To transform it, I just get the value as a JSON object, get the joke, and then return an OK invocation with the given index. This is a method call defined here, which returns a bit of HTML with the title, etc., and everything in HTML, and the joke in there in a paragraph. And you can see here that it looks like a DSL, but it's really not. All of these things, these HTML, head, title, etc., are just method calls. There are calls to the constructors defined by these types. So HTML is a type. It has a constructor which takes a number of children, including a head and a body. Link is a constructor, and I pass it parameters by name, so rel and href, etc. The nice thing with this this syntax and this way of creating objects in Ceylon is that you can see what it's going to look like. We keep the hierarchy of what we're building visible in the programming language. If you had only an interface and an API which allowed you to say, I'm going to create an HTML, store it in a variable, you need a new variable, and then you're going to say, okay, HTML.set head, and then, okay, well, you need a head, you need to store it in a variable again, and then you have a set body, and then you will probably have body.add, and everything is flattened, and when you look at the program, you don't see what's the tree you're building here. You can't see it anymore. So this is something we really try to do in the language. This is very geometric of Ceylon. We try to make hierarchical structures stand out and be easy to maintain. So what are we doing here in the main function? The only thing left to do is to create an application for this package and run it. So what we have here between single quotes are metamodal literals. It means that, I have here a metamodal reference to this package. It's going to scan the package, list all the types, and see which of those are annotated with the route annotation and our controllers. In Java, you get also class literals. When you have a type and then you have .class, that's a class literal. You can send it as a reference to pass it as a value to a method call. In Ceylon, we have references for more than just types. We have references to packages, to modules, to functions, to anything. And when you've ever used the reflection system in Java, you should notice that it's not possible to do this in Java. It's not possible to obtain a reference to a package metamodel. It's also not possible to iterate the members of a package in the Java reflection. You need to use third-party libraries to do this. When you get a package with the reflection in Java, you cannot see what are all the members defined in there and give me all the members annotated with this annotation. It's not possible. In Ceylon, it's quite straightforward. So let's run this. Right. Let's go here. There you go. Every time I hit reload, then I get a new Chuck Norris fact from the database. That's a nice one. So let's go back to here. I'll wrap up by talking about the future of Ceylon. And to be able to properly talk about the future, I need to quickly discuss the past. We've released version 1.0 last year, which was the first production-ready release of Ceylon. We released version 1.1 2 weeks ago now. We made lots of improvements in speed and memory usage. So now compilation is a lot faster, even faster in the IDE. It makes it very much easier to work with large projects. We have over 1,000 and even 1,400 bug fixes. So lots of things got much more efficient. The IDE also was very much evolved and is now completely able to handle anybody's work. We have very few changes in the language in the 1.1 release, and we have much better Java interop. The future, we're going to release 1.1.5 before the end of the year, which will be essentially 1.1 plus a few bug fixes and support for serialization. Serialization is going to allow us to send objects directly from a JavaScript VM to a Java VM, so from several instances of Ceylon wherever they are running. And we're going to release 1.2 in next year with a few new things in the language. I will not detail everything, but some of them are notable, like assemblies, which will essentially allow us to package modules together to create a coherent application. The ability to write modules with bits that are native to both JavaScript and the JVM. At the moment, it's either one or the other, or pure Ceylon. Synchronization with Java 8 features such as the speed improvements brought by lambdas and dynamic and mixins. This was something that currently we compile for Java 7, so this was some of those things we're going to be able to benefit from. AST transformers and the ability to plug into the compiler and be able to tweak the AST when you compile, so that you can have support for instance, link style comprehensions, to be able to define type-safe SQL queries in the language directly, which is going to be very nice. And a number of other things. We have a post on the Ceylon mailing list asking the users to vote for the features they would want to see in priority and those that they're not interested in. So you can participate if you feel that we should be doing something else. And that's about it. Now we have time for questions, I hope. Do we? What am I supposed to look at? Yes? I'll without contrary information, I'll assume yes.
Question, at the risk of sounding stupid. You mentioned unit testing with your Ceylon.
Okay, that's a very good question, and I have a demo for that.
Quick demo.
A quick demo. I mean, I took less time in my whole talk than you, so I'm still allowed to have room for demos. So we have something in Ceylon called the test module with excellent support from the IDE. We have a test. It's very like JUnit, so you just add the test annotation to your methods, and you can use assertions to make sure that the tests pass. You can document assertions as well very easily. And when you select this module, for instance, and you say run as Ceylon test, you see we have a view for Ceylon that is very much like the JUnit view in Eclipse. So you can see why it fails. It says, okay, the assertion message tells you which assertion failed, and the error message, etc. So it's on terms of features, it's on par with JUnit in the IDE. There are maybe some, you can define test suites and lots of things. So maybe there are some things missing. Some of the more obscure things from JUnit are a bit missing from this thing, but everything is there. We even have more features in the IDE where you can compare test runs and see, okay, so between these two runs, what are the tests that now fail or now work? So it's something we use and something very useful. For mocking, no, I don't think we have.
Actually, mocking's kind of a more difficult thing to do in our language than in some other languages because default to final and stuff like that. You can obviously do it for interfaces. We don't have proxies built into the support for proxies built yet. That's something that will come when we do the AST transformers functionality. But generally, I'm not sure that if you have an interface, you can mock it, obviously, but I'm not sure that in general, mocking is going to be a technique that works as well in the language because of, the way we default to the more restrictive options in a lot of cases.
Right.
You guys have a debugger in break transport?
You can use the Eclipse's debugger. We haven't really built anything special on top of that yet, which means that we can't evaluate expressions in the IDE yet. We're going to start working on that now, and Eclipse has an API for doing that, and we'll just make
the Java debugger works.
Yeah.
The only thing is you're not going to be able to, as he said, write when you have in the expression view, you can evaluate Java code with the Java debugger. You will be able to evaluate Java code, but not Ceylon code at the moment. And you're probably going to see a few artifacts of the compilation that we are going to hide behind the scenes when we support this. Yeah.
Sugar on that. Secondly, our JavaScript compiler doesn't yet support source maps, but that's something which is very high on the priority list. So we need to generate source maps information into the compiler code, and that way you'll be able to debug your JavaScript in something like Google's Chrome.
Any notable implementation using this language, and what's the compelling reason for wanting to use this language?
So, if you're looking for, big enterprise scale, production deployments of Ceylon that went 1.0 in November last year, you're not going to find any, right? We have a very active, very friendly user community, and lots of people always on IRC, lots of activity on the mailing list and all that. And so people are using this language, and they're using it. I can tell from the questions they're asking that they're using it to do stuff that's real. But it's very new. All right, we are still building some of those integration things like integration with Java EE and these web framework and stuff like this isn't completely in place yet. So we were telling people until 11 months ago, no, just people would say should we use it? No, don't use it, right? As of 11 months ago, we released 1.0. Now we've released 1.1. Now so it's had that time to kind of get a bit of usage, get a bit of the worst bug shaken out and stuff, and now we're pretty confident in it.
Web application and web services.
Yeah,
I
think one of the best stories we have, for example, is is a story for having a rich client, or I don't know what the single page web app or something, anything like that that's using a little bit of Ceylon on the client, talking to a server, say Vertex, is a great use case for Ceylon. But it's a completely general purpose programming language. Anything that you could use that you would consider using JavaScript for or using Java for, you can contemplate using Ceylon for.
Some people are using it with Swing to create desktop applications. We hope to have some platform agnostic support for GUIs as well. Some people are using it for concurrency as well.
I've seen people have already started trying to build Android apps with it. I think that might be a little bit ahead of where we're at just yet. I would like to productize. Well, yeah, okay.
They got it working.
They got it working, yeah. So
we're going to streamline it. We have already the start of an Android plugin in the IDE for supporting this, and we're going to make it even easier to build.
What's the Android experience like right now? Is it one of those things?
You're going to have to explore and figure it out for yourself how to do it, right? That's why I'm not going out there and telling people to, If you're looking for a productized out-of-the-box experience, it's not there.
I suppose more my question is right now is what are you expecting like have shims that wrap around activities and then it gets compiled, the bytecode gets compiled to Dex, gets compiled, or are those other guys like including the whole Ceylon.jar or whatever and just linking against that?
Yes, that.
At the moment, that's what they're doing. Yes.
Okay. So they're.
But we're working on making the minimum amount of runtime smaller, so that we can fit within the requirements. Right.
Is because it wants to go in places like
Right.
the web browser, places like an Android client. We can't have a big fat.
Yeah.
Thing. So yeah, they're I guess unzipping the car, handing it off to Dex, and repackaging it as a with.
We're going to make this. We're going to make this.
We're going to make it better.
In one
Okay.
Your source depot it's pretty much looks like GitHub. I'm just curious why you create your own specific, depot, and can you do something that GitHub cannot do?
Right. The GitHub and the module repository are completely different products. On GitHub, you don't deploy compiled code at all. You deploy Git sources. On our module repo, you deploy only compiled artifacts. So it's more comparable with Nexus than with GitHub. GitHub is only the source code, and the module repo is about modules. So it could be binaries plus sources, but it doesn't do any building. It doesn't do any collaborative editing. It's really different.
It's for distribution, not
Right.
for development. Okay.
I don't really know much about either project except for what you just said. But how does, I guess, on a high level, this compare to like Kotlin? Superficially, can we come up together?
I don't know if it's really my place to make comments about languages that other groups are working on. Generally when you do that, people tend to disregard your view anyway as biased. So I prefer not to answer the question. Okay, so thank you everyone for coming.